stress that you may learn in material mechanics. And can you tell me which teachers to have this class for you? Teachers one?
Yes.
Material mechanical? No. Sometimes two. Okay. For materials,
of the material. There are three fundamental types of stress: compression, pushing together; tension, pulling apart; and shear, sliding along the liner.
Right? For at the load, the compression stress means in this direction they will have a value. This is the stress occurs in the members here. For tensions, we know if the members at this load, there has a stress that will look like this. And for shears, under the scissors load, we can roughly to know this three, but this two is important common occur. This three. If the structure or the member or the material under different type load, there will have stress, different type stress occurs on the materials.
Plane. And not all materials can resist each type of stress equally. It turns out that concrete is very strong in compression and weak in tension. But you don't have to take my word for it. Here's a demonstration. These two concrete cylinders were cast from the exact same batch, and we'll see just how much load they can withstand before failure. First, the compressive test. Under compression, the cylinder broke at a load of about 1,000 pounds. That's 450 kilos.
Remember this value 450, because for the concrete, under the compression, they have really high values at here. But
for concrete, that's pretty low because I included a lot of water in this mix. The reason is my rig to test tensile strength isn't quite as sophisticated. I cast some eye bolts into the sample, and now I'm hanging it from the rafters in the shop. I filled up this bucket with gravel, but it wasn't quite enough weight to fail the sample, so I added another dumbbell to push it over the edge. The weight of this bucket was only about 80 pounds, or 36 kilos. That's less than 10% of the compressive strength.
Yeah, 10%. This character, because why we propose is 10%, because there are several, like the guys and some others, teachers or other scientists, they do several, they do lots of experiments and measure value. And then they draw this conclusion. And for this conclusion, that will help you to judge. Sometimes we calculate the load we will find. If at this condition we use the concrete on the tension, it will not work because they only have 10% of the compression. We will help you. This is just will be an experience that sticks in your mind. And if sometimes you just can give this conclusion to others and tell them, oh, the concrete just 10% in tension compared with the compression.
All this to say, you shouldn't make a rope out of concrete. In fact, without some way to fix this weakness to tensile stress, you shouldn't make any kind of structural member out of concrete, because rarely does a structural member experience just compression. In reality, almost all structures experience a mixture of stresses. That's no more apparent than in the classic beam. This particular classic beam is homemade by me out of pure concrete here in my garage. Applying the force on this beam causes internal stresses to develop, and here's what they look like. The top of the beam experiences compressive stress, and the bottom of the beam experiences tensile stress. You can probably guess where the failure is going to occur on this concrete beam, as I continue to increase the load. It happens almost instantly, but you can see that the crack forms on the bottom of the beam, where tensile stress is highest, and propagates upward until the beam.
Yeah, look at here. For this beam, is a plain concrete, right? There's no any reinforced, and it's under the load. We increase the load. Quickly, crack happened. Yeah, and the beam broke. Right. So this failure mode we know is a retail, very retail, like you snakes and something you
Fails.
It's a plain.
You see what I'm getting at here? Concrete on its own does not make a good structural material. There are just too many sources of tension that it can't resist by itself. So in most situations, we add reinforcement to improve its strength. Reinforcement within concrete creates a composite material, with the concrete providing strength against compressive stress, while the reinforcement provides strength against tensile stress. And the most common type of reinforcement used in concrete is deformed steel, more commonly known as rebar. I made a new beam with a couple of steel-threaded rods cast into the lower portion of the concrete. These threads should act just like the deformed ridges in normal rebar to create some grip between the concrete and steel. Under the press, the first thing you notice is that this beam is much stronger than the previous one. We're already well above the force that failed the unreinforced sample. But the second thing you notice is that the failure happens a little bit slower. You can easily see the crack forming and propagating.
Yeah, the failure happens slowly because before it broke, we can find some crack happen, develop. Do not like plain concrete beam. Under the load, if it fails, it will be broken briefly.
Before the beam fails.
Yeah, but it's also
This is actually a very important part of reinforcing concrete with steel. It changes the type of failure from a brittle mode, where there's no warning that anything is wrong, to a ductile mode, where you can see the cracks forming before a complete loss of strength. This gives you a chance to recognize a potential warning that anything is wrong
Yeah, and for this denominator, I ask a question, okay? Yeah, if for structures, the failure mode look like this, or will the brittle failure or will ductile failure, can it have any benefit for person or for people? Yes, I want to say, if the structure failures in this failure mode, have any good, so see something. So why you think that? If the failure like this, ductile failure.
It gives a warning that the failure is gradual. It's not instant like the brittle failure. So it gives a chance for you to see that something is wrong. It's not as instant as the brittle one. So the brittle one is actually very dangerous because once there's a failure, you need to verify. That that's it.
Okay. Thank you. The guy. Yeah. Your name is Chen Dawei. Dawei said. Dawei said. For this mode, very very dangerous because it's failure very suddenly, right? But for this one, ductile, it gradually happened failure. It can save the time. For people, if as a person, right? Persons come to a beam, come to near some buildings, we see there's some cracks. Just a warning, right? Warning to let you know, oh, this is dangerous. But if this beam, we see, it's there's no crack. We come to here, but the structure is belong to like the plain concrete. Oh, suddenly happened. There's no time for us, to know, right? So actually, for civil engineer, when we design a structure, we prefer the structures look like ductile. Do not like the brittle failure because it's really dangerous. Yeah. What else? For this one, this could benefit. And what else? Can anyone? Another idea? Yeah. It's the main reason.
With ductile mode, where you can see the cracks forming before a complete loss of strength. This gives you a chance to recognize a potential catastrophe.
Take the video back way broke there. This one? No, in front again. This one?
There.
Yeah.
So the second one,
This one.
that one is reinforced, right?
Yeah, reinforced.
Right. Why does it look like the steel also breaks?
Yeah,
It does.
yeah, because here he gives the bigger load. Of course it will feel, but look at here, he compared the slim load.
Important part of reinforcing concrete with steel. It changes the type of failure from a brittle mode, where there's no warning if anything is wrong, to a ductile mode, where you can see the cracks forming before a complete loss of strength. This gives you a chance to recognize a potential catastrophe.
Steel also breaks.
I thought it would be way more than
The one
Yeah. Because here, for this one can be the larger load. And also there's another benefit I hope everyone can know it, because for this one brittle, because we pay a lot of attention or we use a lot of material resources to build the structure, right? For this, if it broke a failure like this one, they will not give us the time to repair the buildings, right? But for this one, if sometimes the crack happened, we can use some other method to repair. We will know the building cannot bear this load, so we should use some other things, material, to give here to let the buildings still work. Because we know for place to build a building, it will cost a lot of energy, lots of resources, lots of material. It will be broke. It will just a catastrophe, just waste the people's money, time, and effort. But if for buildings, we can use some method to repair. You do not let it break. For this ductile failure mode, just a warning to let us to know which time that we need to repair the building. Right? But this also another benefit of this type.
For a complete loss of strength. This gives you a chance to recognize a potential catastrophe and hopefully address it before it occurs. Rebar works great for most reinforcement situations. It's
And in these videos, it also introduced another type, pre-stressed structure. Okay, that's
relatively cheap, well-tested, and understood.
different.
But it does have a few disadvantages. One of the major ones being that it is a passive reinforcement.
Because the reinforcement
Steel
is
lengthens
just a
with stress, so rebar can't start working to help resist tension until it's had a chance to stretch out. Often that means that concrete has to crack before the rebar can take up any of the tensile stress of the member. Cracking of concrete isn't necessarily bad. After all, we're only asking the concrete to resist compressive forces, which it can do just fine with cracks. But there are some cases where you want to avoid cracks or the excessive deflection that can come from passive rebar. For those cases, you might consider going to an active reinforcement, also known as pre-stressed concrete. Pre-stressing means applying a stress to the reinforcement before the concrete is placed into service. One way to do this is to put tension on the steel reinforcement tendons as the concrete is cast. Once the concrete cures, the tension will remain inside, transferring the compressive stress to the concrete through friction with the reinforcement. Most concrete bridge beams are pre-stressed in this way. Check out all that reinforcement at the bottom of this beam. Another way to pre-stress reinforcement is called post-tensioning. In this method, the stress in the reinforcement is developed after the concrete is cured. For this next sample, I cast plastic sleeves into the concrete. The steel rods can slide smoothly in these sleeves. Once the beam cured, I tighten nuts onto the rods to tension them. Under the press, this beam wasn't any stronger than the conventionally reinforced beam, but it did take more pressure before the cracks formed. Also, this one wasn't quite as dramatic because instead of failing the actual steel rods, it was the threads on the nuts that failed first. I hope these demonstrations help show why reinforcement is necessary in most applications of concrete, to add tensile strength and to change the failure mode from brittle to ductile. Just like the last video, I'm just scratching the surface of a very complicated and detailed topic. Many engineers spend their entire careers studying and designing reinforced concrete structures. But I'm having some fun playing.
Yeah, I downloaded it from the YouTube. And so if you can go to YouTube, you can to find some interesting videos for learning. Yeah, it's a really good platform. There also have English word. Maybe practice the English, right?
Right.
Yeah. And here's why you stand here? Okay. Yeah.
Sleeping.
Yeah. Good. Yeah, so here's this is a very basic stage, right? Yes, and for the video, talk about this is the plane. There's a no reinforced plane, concrete B. And for the second, the guys use the reinforced beam. Yeah, reinforced. There's the steel bars, right? And another he mentioned a different type. This is the pre-stressed. Yeah, pre-stressed. And for this one, we only put the rebars in the concrete. The reinforced do not, the steel bar do not suffer any force or load. That means it's the passive, because the load comes, the steel bars have the stress, right? This is the passive. But for here, because as an engineer, right, we sometimes has another idea we want to change or something. Here, so we realize it's under the load. The rebar will suffer the tension. So here we just at before we give the force, give the load in the steel bars. Here is in the video they use the screw, right? Screw, and to like this one, yeah, give the force, give the load to here. Yeah, it change the load pattern, something like that. And for here, it's the active. It's in the pre-stressed. Yeah. So for these things developed, and this three type of the load pattern, every student can familiar. And this one may introduced in your postgraduate or later. And in our class we just talk about these two things. Okay, these two things. Yeah, definitely. These two things also the basic, right? Basic for you. If you're familiar about this one, in another day you have this course, you can easily to know that. Okay. And coming back. Yeah, okay. Here's this is the three reasons to explain the reinforced concrete why these two materials can work together. And for now, yeah, here's nowadays people use the concrete, use the steel. They developed lots of different type structure buildings. Yeah, here's at least here they have his own academic name, like pouring concrete. Yeah, I remember the first class. Some guys, one student asked me if there's a no steel bars, there's a no gravels, then is it a concrete or not, right? Yeah. Oh, you asked, right? Not you. Yeah, plain concrete, and yeah, it also belongs to concrete. Okay. Yeah, lots of concrete. Yeah, different type. Okay, that's to roughly to know that what's the plain concrete and look like this here. Because the plain concrete, they only have the concrete. There's no steel bar, right? No steel bar. So we used this type of concrete on which place? Yeah, for foundation, right? Foundation of because like a building, right? This is the soil, and this is the foundation. This is the building. For building, they give the gravity, they give the load to the foundation. For the foundation, they only suffer the compression, do not need the tension, right? So at this condition, the plain concrete can use here, Yeah. So this is the plain concrete structure. Yeah, like fulfill some empathy has to change the soil character, and will be used here. And the reinforced concrete that will be normal for steel bars put and the concrete to pour and here, and then we remove the mold. That's it, the reinforced concrete structure. Look at here. In reality, there's a lot of steel bars. So not the for the steel bars like the video, they only use the two at the bottom. For the bottom steel bars at here, they suffer the load. But some steel bars used like this, stir rod, here is just give the shape to because the mold can have the shape, but cannot keep the yeah. But we use this one in to strengthen the shape. But here you just need to know there's a lot of steel bars used in the reinforced concrete. And the two steel bars that is to resist the tension. And on the bottom, other is another function. And pre-stress mentioned in the videos that use the bridge on the bridge. They give the first force on the rebars. And for the concrete filled steel tubular structures. You look at this is the column, the pipe, and how it should look like. That means this is the steel bars, and we pour the concrete on the this one here tubular. So it looks like this is the steel steel bars and pour the concrete in there. Because for the material, right? If the concrete under the compression, they will have look like the figures on the body that on the compression the load. So here, we use the steel bars. We will prevent the deformation. So it will change. Yeah, it will change the character. So there's a lot of different types that use the steel and use the concrete that to change the members' character here. The steel reinforced concrete. Yeah, and here's we use not the steel bars, the fiber. This type always used in the repair structure. Before some crack happened, some people, the engineers on the bottom, they use this FRP, this material. If you interested about this material, you can search it and to find another things out of often class. Because here I can see something. That FRP, they have a really good intention character. This character is a more bigger than the steel bar. But it's really expensive for this material. But we believe in the future when our industrial production have developed, these things will not cost a lot of money. So here, we only use some buildings repair or use this material to the structure. And the steel concrete composite structure. These structures also commonly used in the bridge. And how does this type structures look like? Because for reinforced beam, the steel bars just like on the bottom, right? But for bridge, this part they use the concrete, and this there they use the steel. This is a composite structure, composite structure. And sometimes it will to box girder. Because why it's commonly used in bridge? Because for bridge, we know the gravity will cause lots of load on the structure. Use steel bars to replace the concrete because it can save the material, can reduce the gravity load on the beam. Because if here we use the concrete, right, the volume will be so large, but you still the values you reduced. Yeah, that's the reason some place they propose the steel concrete composite structure. This also belongs to a type of the structures here. And the fiber reinforced concrete, that's use the fiber in the concrete. Do not like on the surface. Just to replace the steel bars. Yeah, and this is the chapter 1, section 1. We talk about And here's there's a story, okay? Yeah. Who, yeah, if someday, maybe your children or your other students ask you, who invent the cement? You need to know this guy. Name is Joseph Aspertin. Right? Aspertin. This guy. And yeah, this one, this guy. They use. Why I mentioned here? Because he has a good quality. He is really curious about the life on some phenomena area. He curious in he keep his curious in the life. Before he is really poor. Yeah, he is not a rich man. He worked for others, but he keep his curious. One day he found the limestone. They just capture some limestone and clean and use these two materials together on the different proportion. Yeah, maybe he just listen from other guys, or maybe just like listen from his teacher. Yeah, his teacher I've used this, but I not carry the experiment for it. But for this guy, yeah, this guy, he know the idea and he do it by himself. He use a different proportion, the limestone and clay, and they found after he add some water, yeah, these things will be hard because after the hydration process, right? The thing it will be hard. So yeah, he applied a patent. Yeah, patent. Yeah, then he'd be the rich and marry a really beautiful girl and live a really happiness life. Yeah.
So when you married a beautiful girl, but you became rich.
Maybe, but do not say like that. But the story is like this. Yeah.
Our life is not fair.
But he through his hard work, right? He keep his curious and find the things and do the things.
So through his hard work, he didn't have a wife.
No, do not like maybe also the beautiful, but not happiness.
So the happiness came after the money.
Yeah, occupied a lot of percent, I can think. Not all the thing, but may occupy a lot because. So how to say good quality life? Yeah.
Money.
Can
Money can
you?
buy happiness.
Money can buy happiness.
Yeah,
What money can buy?
money can buy.
Money can buy happiness.
Yeah, money is not really important, but it's important, right?
It's important.
Very
important.
important.
How to express? But yeah.
But she even know that guy, it's only because of money that's married.
Next.
You know?
The details I'm not. But the stories I listen, I read the news look like this because he threw his heart. Because before he just his father, yeah, this guy's father is a sure his father just repaired shoes. And he followed his father. Yeah, but if he do not find the cement, he will follow as a sure. But but he through his hard work, and he can change his life. Yeah, change his life and live really good. And do not really care about the how why the story have developed like this. But what I want to express is that I hope my students keep the curious in the life, right?
Yes.
And try something, and maybe you will find a really new, different material, and then you can apply the patent, and a really different life. And this, I don't believe this story. Okay. No. And see here. We need, for we now learn the principle concrete. We need to know who, invent the statement. Okay, this guy. And this in the early stage, let's do not use this one in the building construction because in the early before we use some wood, right? Cut the tree, and it's not friendly to the environment. So here use this materials and to replace wood, and the wood also have another disadvantage or something. But his image and just like really big change for in others construction buildings. Then later, this guy they use the concrete to construct a boat. But of course, we put this boat on the river to be seen. It cannot float, right? Because at this stage, people just try and try several different things. And then the first use the reinforced buildings in New York. The second stage. Okay. Last number.